All right, everybody, hello and welcome to our first topic in the course, which is the scientific understanding of behavior. So I think this is an important place to start because before we get into the sort of nitty-gritty of the class and all of the specific types of research methods we'll be talking about, there are some foundations or ideas that will underlie everything else we will talk about in the course. So let's go ahead and get into it. All right, the scientific understanding of behavior. So remember that psychology is a science and we follow the rules of science. So we'll be talking about the scientific method here, but we'll also be talking about just general rules of good science, right? How do we do science well? And what do we need to think about when we are addressing research, whether we're reading research, conducting research? So I always get on my soapbox with this class, right? Even if you're not interested in going into research yourself, research is all around us, right? There's market research, people trying to get you to buy things. There's scientific research, research on big pharma. It's all around us, and people will use it to manipulate you. So the stronger you are in understanding research methods and statistics and how they all work together, the better consumer of information you will be. And this is in your personal life, your professional life. We use a lot of skills in this class that translate to other fields, right? We're talking specifically about research methods in psychology, which poses its fair share of difficulty. But research methods are consistent across fields. That's why we have the scientific method that spans across multiple fields. So as we're talking about these things, we'll focus on the challenges of psychology because we're all in psychology. But it's not to say that these methods don't have a place elsewhere in science. So, all right, why do we conduct research? This is a good question, right? What's the point? We will be conducting our own research in this class, and you'll get a taste of the process, all right? Research is not an easy process, so why do we do it? Why do we go through the trouble? And it's to answer questions. It's to answer questions that we think deserve answers, all right? And for every question, we can develop a research model. So a research model is how we plan to answer that specific question. Some are easier than others, right? Maybe I have a research question about how many students in my class are socially satisfied, all right? Are we meeting our social needs? All right, if I'm interested in people in my class, right, I can ask them some questions and I can answer that question for myself. Some questions are not so simple, so I have a few questions I pose here. Why are we attracted to some people and not others? All right, interesting, a social psychology question. Attraction is a vast subject in its own right. Maybe we know why people are attracted to each other, but maybe we don't, right? We've maybe heard that opposites attract. We know that that's not so true for long-term relationships. But attraction and our social psychology and how we interact with other people is a question that we still don't completely understand, though we understand it in some facets. Why do we dream? People love to talk about dreams. You're going to do a research project in this class, and maybe you want to ask people about their dreams, but I'll tell you this right now. We don't understand dreams hardly at all, right? Even with researchers working on it constantly. And dreams have been in question since the beginning of psychology. Freud was very heavy on the idea of dreams being significant to our psychological processes. But the simple question of why do we dream, we've yet to answer that, right? We don't know. What causes depression and what can we do to alleviate it? It's a very practical question in psychology. Many of you might want to go on to be counselors or psychologists or psychiatrists, and this type of research that informs psychological disorders like depression will be part of your career. Can we improve our memory, and if so, how? We'll talk about memory a lot this semester. Our memory is bad if you're not already aware. The human memory is very faulty, right? Our short-term memory cannot hold very much. Our long-term memories are largely unreliable. So this is not to give you an existential crisis, but to make you think about how we would go about measuring something that's so difficult to measure, right? Can we improve our memory? is another great question. You'll see gimmicks, you'll see vitamins that say they'll improve your memory, you'll see apps, phone games that say they'll improve your memory. But to really answer this scientifically is complicated, right? And not entirely clear. How about what makes us aggressive? And can we do anything to make us less aggressive? Another great question that has social implications as well, right? We live in a violent society to some degree. If we can understand the mechanisms underlying aggression, we might be able to alleviate or prevent aggressive acts in the future. So, and while we're talking about all of these questions, we can think about the interdisciplinariness of these ideas just within psychology, right? We know that there are neural mechanisms or biological mechanisms that underlie aggression, as with our dreams, right? So we can start to think about how these questions are multidimensional and how there are research models we can use to address any of these questions. All right, so that's why we do research, right? To answer interesting questions or to solve problems. But what is research? Research is a report of information, all right? It's the who, what, where, when, and why. You've maybe heard this before for other types of writing, and it does apply here for science as well. When we publish a piece of scientific work, we want to know who wrote it, what it's about, when it happened, right? The year it was published, where, who published it, and why. What was their motivation for publishing it? We live in the information age, right? With the internet, we have many different platforms that publish information. So when I say published here, I'm not talking about published on the internet or on a website. We're talking about published in a scientific journal. So I have a scientific journal over here. It's called Science. This is one of the biggest scientific journals there are. It's a very well-respected journal. So to get your article in here, if you write up a research report, say you do some fascinating research on why we dream, let's say you're a cutting-edge dream researcher, and you write up a research report, you collect some data, and you want to make a statement about dreams. You would need to have it peer reviewed. And what is peer review? It means peers in your field review it anonymously to see if your science is good, to see if you followed the rules of the scientific method, and to see if your claim seems to be reasonable. And we'll talk all about reasons why a claim or a study might not be good, all right, or why it might be good. We'll talk about all sorts of topics like reliability, validity of studies, our sampling methods, how do we get the individuals that we're using for our study. So scientific research, or the research we'll be talking about in this class, is something very specific. It's published in a scientific journal and it's peer reviewed, okay? All of the research we will read in this class will be published and peer reviewed, unless we're, say, having a discussion about some bad science, in which case it might come from somewhere else. But this is what we're talking about. We're going to learn how to use databases to find this type of research, to find research that's been peer reviewed by other professionals in the field. So we'll keep this in mind, right? This will inform us for the rest of the course here. So why does research matter, right? Okay, why do we do it? All right, we already talked about why we do it. We do it to answer questions, which can be interesting. But sometimes we're answering questions that don't have a lot of, say, public or social impact, right? Maybe I want to do a study on how cute my dog is, right? I could do that study, but does it matter to anyone but me? It doesn't. However, there's lots of research that applies to many, many people. So I have an example here, parent opinion about vaccine safety. So this is relevant, right? This is from an older study. This is from, I believe, around 2015. All right, so vaccines are always a hot topic now, and we're currently sitting in a bit of a, this is a hot topic right now, that's all I'll say. But why does research matter? Because public policy can change due to research findings, right? We have the FDA, we have the NIH, the National Institute of Health, the Food Drug Administration, the FDA. They inform policy and policy changes that will hit our social sphere, right? And we have the same impact with psychology research, right? How do we treat those who are suffering from mental illness? That eventually gets to our government, right? We have issues in the prison industrial complex, which deal with those who are mentally ill. So we need research. We need information on these topics to make well-informed decisions about them. Research can be used in court cases. It's used for the law. We'll talk a bit about that throughout the course. And then most importantly, information forms opinions, or lack of information informs opinions. So we do our best with the information that we have, right? And we're concerned with the who, what, where, when, and why, where it's coming from. Do we trust that information? But again, the important thing here is that research ultimately has a larger impact than you might think, right? A single paper might not do much to our social structure, but if we have a repetition of findings or results, that might ultimately go on to change public opinion about any given topic. So I do have an image here about parent opinion on vaccine safety. So compared to 1 year ago, and if you're not up to date on the vaccine debate, vaccines were really debated in terms of safety within the last decade or so, and were attributed to rising autism spectrum diagnoses, among other things. So we're interested in knowing how people feel about them, right? Because they're a public safety concern in themselves. So here, compared to what I thought a year ago, I think vaccines are safer, about the same, or less safe, right? So we can see general trends in the data to see what people think, right? And of course, this is a product of who we're asking, and we're going to get to all of that throughout the semester here. Okay, so different types of research. We're going to talk about all of these in great depth later on, but it's helpful to get used to this sort of language as we're talking about research. And you should have had at least a quick overview of these in your statistics course, so we'll be reviewing them here. So we have observational research, or what we call descriptive research. This is research that we do not intervene with, okay? Think of it as watching kids play on a playground and marking how many aggressive behaviors they show, right? We're not putting them in a situation, asking them to do anything specific. We're not manipulating anything, right? Adding in, say, maybe an aggressive child and see how they're reacting. We're completely hands off. We're observing and we're describing. Right, just observing and describing. Correlational research looks at relationships between two things. So we're not directly intervening here either, but we are, say, selecting which variables to compare to each other. And then we have experimental research where we do meddle, right, or manipulate different pieces of the study. And experiments are so important because they can attribute cause. They are causal. We're going to talk about the word cause a lot because cause is a word that we have to dance around a little bit in science. People will say that one thing causes another when what they really mean is that one thing is related to another. Again, much more on this as we go, but it's good to get used to this language out the gate, all right? Some other language we want to get used to. This is our intro to independent and dependent variables. You'll be coming up with your own independent and dependent variables in this class. Psychology variables, we'll talk all about them. But independent and dependent variables are crucial to any type of experimental design or to any type of study. And you've maybe heard definitions for these before, and they can often be a little bit confusing, I think. I think that the language used to describe these can be challenging. So we're going to start very, very simple. The independent variable is a predicting variable. It's a predictor. We think that it's predicting something else, all right? And that something else is the dependent variable, or the outcome. So I have this example over here, watering a plant, giving a plant fertilizer. Those would be independent variables or predictors. We might say predict that giving a plant water and fertilizer would ultimately result in the outcome of more plant growth, right? So predictors and outcomes. Because you've maybe heard the word manipulate. The independent variable is something we manipulate. And in that case, we see this in this diagram, right? That we can manipulate how much water we say give a plant. But we'll get into this later with correlation or regression. Maybe you think that gender predicts anxiety symptoms. Well, we can't manipulate somebody's gender for our research purposes, right? That would be one, difficult, and two, unethical. But I like this verbiage here. I like this language. The independent variables are predictors and dependent variables are outcomes. So if you start to think of them this way, it should make different research situations clearer as we go. All right, and then a little bit more on cause, all right, another major building block of research, because what we're going to start doing is being very careful with the word cause. If you hear the word cause, if you read about it and say a news article, right, that one thing causes another, you should raise an eyebrow, right? You should be skeptical, which is something else we'll talk about here in a minute. But cause is something specific. It means that the independent variable caused the dependent variable, and nothing else contributed to that. And what we'll come to find is that in science, it's very hard to do. It's very hard to look at things in a vacuum in that way. We often have what we call confounding variables, which wholly or partially account for the relationship between two other variables. These are problematic in all types of research. We can never completely rid of confounding variables. And then I just have the word error here, which looks like an error in itself, right? It's just floating over here, but error is all around us as well. If you remember in statistics, we often calculate for error or standard error. So when we take our standard deviation and divide by some function of our sample size, because what we're basically admitting is that we have a sample, but it's not everybody that we're interested in measuring, right? So our sample is not perfect. Therefore, the statistics we get are not perfect and that we have some error. So when we say that one thing causes another, we have to be very, very careful. And we have to be pretty certain of it as well. It's something that we want to see time and time again. So we're going to get more comfortable with using words like relationship. There's a relationship between two things, because then we could go on to explain that relationship. But saying that one thing causes another, it's a very strong statement, and it's not as likely as you think that we truly unearth the cause and effect of two things, right? Take something as complicated as depression, right? What causes depression? We could probably make a long list right now of things that contribute to depression and have a relationship with depression, but it would be difficult for us to say what causes it, right? All right, so that's causality. We'll be careful with that word. If we want to say that something causes another, we have to have randomized assignment, and we'll talk a lot about this when we get to experimental design. But we need something that looks like this. We need a control group and an experimental group, right, if we're doing an experimental research design. The experimental group will receive something the control group does not. Let's stick with depression. Let's say that we're testing a new depression medication. So we would take a group of participants, right, people with depression. We would randomly assign them, right, that's the word random assignment. We would randomly assign them to one of two groups, either a control group or a sort of baseline, or those that maybe will not receive a depression medication. And the experimental group will receive the medication, and then we'll compare the groups to see if there are any differences. If the experimental group, which receives the pill, sees a reduction in depression symptoms, we might be able to say that that pill caused a reduction in depression symptoms because we have something to compare it to. When we do something like a correlation, we don't have that. We don't have a baseline or a group that we can point to and say, hey, we've seen a marked change from this other group. So that's just our basic overview here, but we want to be careful with cause, all right? That's the main piece here. And let's talk about it some more, right? You've maybe heard this phrase as well. Correlation does not imply causation, all right? Meaning that if two things are related, it doesn't mean that one caused the other. All right, so here we have, I like to do this in all my classes, share what we call spurious correlations, or relationships that exist that we can't necessarily explain. All right, so in this case, we have rock music quality versus oil production, the US. Without having much understanding of how to, say, interpret a graph like this, we can at least see that the trends of the two seem to be similar, right? So it would be ridiculous to say, right, that the quality of rock music caused an increase in oil production or vice versa. So it's funny, right? It's funny to look at this and say, haha, so silly, right? But it's not so silly when it's a real issue, right? Or some very real variables being used. This is another one for laughs a little bit. Not that murder is funny, but Internet Explorer use versus murder rates. We see a trend here, right, or a relationship between two variables, but it doesn't mean that the downfall of Internet Explorer also caused a downfall in murder rates. And in fact, there's a pretty interesting idea behind this sort of trend because murder rates have plummeted over recent years. And it's thought to be because of the internet and because of intelligent systems that make it more difficult to carry out such a crime. So we can explain this a little bit, right? But it seems a little funny or ridiculous to compare it to Internet Explorer specifically. But then we have something that's not so funny or not so ridiculous, right? We have a correlation here that's implying a relationship between autism diagnoses and organic food sales. So my background is in autism. I've done research on autism spectrum disorders using neuroimaging. So autism is, of course, complex. We do not know the cause of autism. All right. Well, some people might say they do, but science as a whole does not agree that we know the cause of autism. So what does a graph like this mean? All right. What we have here is a very strong correlation. If you remember correlations from statistics, correlations can range from -1 to +1. The closer you are to -1 or +1, the stronger the correlation. The closer to 0, the weaker the correlation. This is a correlation of 0.99, almost a perfect correlation, meaning that there's a very strong positive relationship between these two things, autism diagnoses and organic food sales. So, if a scientist looks at this, they would say, interesting, right? Kind of give it some thought and think about why this relationship exists. The problem here is that this made it into the public sphere, that people in the general public saw this graph, saw this information, and said, organic foods are causing autism. There was an outcry for this, that organic foods, how organic foods were being treated, was leading to more autism diagnoses. And a group of people grabbed onto this and ran with it. And we can't blame those that are not scientifically literate for doing this, right? People want answers to their questions. That's why we do research in the first place. But as a scientist looking at this, and the scientist that you're all becoming, right, by taking a class like this, you should look at this and be skeptical, right? You should say, okay, a relationship is here, but maybe there's a sort of confounding variable, right? Or something else that's contributing to this relationship. And what's contributing to this relationship is time. It's right here on the graph. Organic foods have become more available in recent years. Of course, this is an older study. This is from, I believe, 2010. This was put out, 2011 perhaps. Organic foods have become more available, and autism diagnoses have been rising. Again, we don't know why. We can't say the cause and effect, but we have some ideas. The ideas being that autism diagnosing is more widely available through schools and other programs. And we can point fingers at others, right? It's why vaccines and autism have been sort of a hot topic, less so now, but have been in the past. So we can look at funny examples of this, but we can look at examples of this that are alarming. And beyond this, people misuse statistics all the time, right? People might create a correlation between, say, gender and autism, but that's impossible. We can't correlate a categorical variable like gender. We have to have a certain type of data, and we'll be reviewing types of data in a future topic. So correlation does not imply causation. Even if you've heard that before, we're going to start to think about it more, right? We're going to start to really think about what this means and how we should be thinking about it in the research that we read. All right, so in addition to being careful with the word cause, we're also going to be careful with some other words, things like prove or the truth. We rarely prove anything in science. We rarely unearth the truth. But what we do is we accumulate evidence to suggest something, right? And once we have enough evidence to suggest something, that's when we start to hold something as true, all right? And we'll even use that word lightly. Because what we're basically saying is that it's true for now, or it's our best understanding right now, or it's what we have evidence for right now, and we know that it can change. So we'll talk a lot about this, as I keep saying that, right? But we just have a lot to talk about. This is our very first topic here. But we want to be careful with this language. We don't prove anything. We don't find the truth. We talk in a very specific and deliberate way, much like how you learned in statistics, where we either support, we retain, or we reject the null hypothesis, right? But we never accept it, right? We never accept the alternative or research hypothesis. We're just accumulating evidence, right? That's what we're doing. So I really like this comic. I think it's great because it's about cause, right? It's about cause and attributing our information as the truth when it might not be, right? So the last thing I'll leave us with here is just about skepticism. And skepticism feels sort of like a bad word, right? Like it's bad to be a skeptical person, but I assure you it's not. I like to use the term healthy skeptic, right? Be a healthy skeptic. When you're faced with some research, you should think about the who, what, where, when, and why, right? Where did this come from? What are they trying to get from it? When was it published? Is it recent? Is it old? You should meet claims with skepticism, all right? You should ask yourself as well, when you hear a claim, you should ask yourself, how would I have answered the same question? And that's what this class is all about. It's about our research methods, right? What method might you have used to address that question? And then look for repetition and consistency. So we'll be talking about the scientific method in this class. And the scientific method, it's not a set of steps that you do when you're done. It's a set of steps that when you get to the end, you start right back at the beginning. It's a cycle. And we're looking for consistency to put some weight into our claims. All right, so we made it through the first lecture. All right, very good. So as always, just be in touch if you have any questions on this material, and I'll see you over in the next one.